The one that I don't really pay a lot of attention to is average, but here we go. Let's look at it. The average of a series of measurements should not have more significant digits than the measured values. If a person uses a bathroom scale to measure 53.5, 52.3, and 49.5, each measurement has 3 significant digits. Therefore, the average can only have 3 significant digits and should be recorded as 51.8 instead of 51.7666666, blah, 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 blah. Okay? So look at example 2, or practice 2.1a. 2.1a. I want you to do 1 through 6. I'm not going to do 1 through 6 with you because now I already did example 2.1 for you. Okay? But I want to do 7 through 10 together. Rewrite the result of each calculation using the correct number of significant digits, rounding if needed. Okay, so look at the first one. They do the calculations with you. It's adding and subtracting. This one's subtracting. So you have 88.17, right? 88.17. Okay. How many significant digits are in 90? 1. How many significant digits are in 1.83? 3. So the least accurate number is 90. And it only has a significant digit in the what? In the tens place. Okay? So that's the last significant digit in the least accurate number. So you have to round your answer to the tens place here. Okay, so what's your answer going to be? Weird, right? It's going to be 90. Okay, because why? Here's your tens place. This is going to make it go up. So your answer is 90. Okay? Look at number 8. 2.000, this is multiplication, times 25.0 equals 50. Okay, remember the rule. The answer is rounded to the same number of significant digits as the least significant factor. Okay, how many significant digits are in 2.000? 4. How many are in 25.0? 3. So your answer has to have 3 significant digits. How are you going to get your answer to have 3 significant digits? You can do this. 50.0. Okay, once you put that point there, these 2 zeros after are significant, so 500. Okay? Look at number 9. 91.4 is your answer. How many significant digits are in 5.370? 4. How many significant digits are in 86.03? 4. Okay, here's the thing though. 86.03 only goes to the hundredths place. So your answer should not go past the hundredths place. It doesn't have any sentido that you can say that you know the digit in the thousandths place when one of your measurements only goes to the hundredths place. What if that was 86.034? We don't know. Okay? So we're going to bring your answer only to the hundredths place. And how are we going to do that? By putting a 0 right afterward. And that's all you have to do. Okay? Look at number 10. We're dividing this time. How many digits are in 56.0? 56.0. How many significant digits? 3. How many significant digits are in 13? 2. So this one can only be rounded to 2 significant digits. So what's your new answer going to be? 4.3. That's it, 4.3, because you're going to round to right here, and this is a 0, so 4.3. Okay? Okay, let's see what else. Scientific notation. I'm just going to teach you scientific notation with the practice 2.1b, okay? I'm not going to, because a lot of you, most of you, or all of you have seen scientific, I'm thinking, eSmart, you have seen scientific notation as well. That, scientific notation is all over your math books. Okay? It's a way to write very small numbers or very big numbers easily, right? But honestly, guys, it's the last thing I'm going to do on this video. So if you turn it off, because you already know how to do it, I will not be offended. Okay? So, here we go. But if you want a review course on it, it's totally fine. Okay, what you do for scientific notation, you're going to take a normal number and write it in scientific notation. You need to understand that every whole number has an invisible point, decimal point, right? Now, the format for scientific notation is that you have only one whole number, that's not a zero, times 10 to a power, right? So you're going to have to move this decimal point to get it where there's only one whole number before the decimal point. Okay, so you go 1, 2. You move it over 2. And you make this 2 times 10 to the 2. Okay? Why? Because you had to move this over here to get it to where you needed to go. You had to move it over 2 places. But when you go to write this again as a normal number, where are you going to have to move that decimal point? You're going to have to move it to the right. How many times? 2 times. For it being a positive exponent. So, your answer is 2 times 10 to the second positive. Sometimes it's negative, sometimes it's positive, and we have to see why. But it's positive here because when you go to make this a normal number again, you're going to have to move that decimal point to the right to make it bigger. So, to the right is always positive. 2 times 10 to the second. Okay? Look at number 2. Okay, there's an invisible point right here, right? You're going to move it over till you get to the 3 again because you only can have one whole number in front of a decimal point. So you move it 1, 2, 3, 4. So it's going to be 3.2 times 10 to the 4th. You ask yourself, is it supposed to be positive? Yeah, because in order to get to my original number, I have to go to the right 4 times. Okay? Look at this one. Now this one, you're going to have to move this way. 1, 2, 3. So it's 5 times 10 to the 3, but is it going to be negative or positive? It's going to be negative this time, you guys, because look, to get back to the original answer, you'd have to go like this. 1, 2, 3. Okay, so it has to be a negative 3 right there. Okay, and then this one right here, first you have to write it into the right form. That's going to be 0.0009. Me imagino. 1,000. Yeah. 0.0009. So you're going to go 1, 2, 3, 4. To get to your point, we're supposed to go 9 times 10 to the negative 4. I automatically know it's negative 4 when it's that kind of decimal point because look, you're going to have to move it over this way to get your original answer. Okay? That's how you do scientific notation. But now, to do it backwards, what if you have the scientific notation and you want to write it into a real normal number? That's the easiest one. What I just taught you is the more complicated. But thankfully, they are keeping it simple for right now. Okay, look at number 5, 6, 7, 8. 5, 4 times 10 to the 4th. 6, 2.2 times 10 to the 8th. 7, 8.0 times 10 to the negative 3. And 8, 9.5 times 10 to the 6. Okay, all you have to do on this, super, super easy. You put your 4, okay, invisible point. You go over 4 times to the right because that's what it is, because it's positive. Okay, so you go 1, 2, 3, 4. That's 0, 0, 0, 0. That's your answer, 40,000. Okay, down here, 2.2. 2.2, we're going to move it 8 spots. 1, 2, 3, 4, 5, 6, 7, 8. 0, 0, 0, 0, 0, 0, 0. 220 million. Okay, this one's 8.0, but you move your decimal point to the left. 1, 2, 3. So your answer is 0.008. Okay, and then this one you're going to move it to the right again because it's positive. So it's 9.95. 1, 2, 3, 4, 5, 6. So that's 9,950,000. 9,950,000. Okay? So there's your mathematics as a language of science lesson for today. Sorry we went into 2 videos, but it was important information. Okay, don't forget there's 2 concepts to do 3 to 5 sentences on. Then you do the practice 2.1a and then the section review 2.1. Bye.